This is, oh, now it's working. That was weird. Anyway, hi everybody, this is Mrs. Lehman. You're here in my 6th period class today. We are going to be learning how to do greatest common factor using a factor tree. We're going to learn how to create the prime factorization of a number as well. So the first thing that we have is a bell ringer. It says, what is the sum of 14.6 and 9.07, otherwise known as 14 and 6/10 and 9 and 7/100? When you add those, what's the important key to adding decimals or subtracting decimals? Rihanna?
Line up the decimals.
Very good. Line up the decimal points. You've been doing this for years. Even when you were in elementary school, you just didn't realize there was a decimal point at the end of those numbers. All right, so line these up. We're adding. Sum means add. So I'm going to put a 0 placeholder right here, and this addition's pretty easy. 7 plus 0 is 0. 6 plus 0 is 6. 4 plus 9 is 13. Carry the 1. You get 23 and 67/100. Raise your hand if you got 23 and 67/100. Woohoo! All right. Find the product of 5/100 and 7/10. So product of these two numbers. What operation does that mean we need to do? Maddie?
Multiply.
Multiply. Very good. So I'm going to put the one with more digits on top. I mean, technically in this case, I don't think that would even matter because, you know, you're just really multiplying 5 and 7. Right? So 5 times 7 is 35. Notice I did not line up the decimal points. You do not need to line up decimal points when you're multiplying, okay? You just multiply as if it had no decimal points. Then you count the number of spaces or places past the decimals in that set of factors there. So you would count these up. You have 3. So you're going to start with your decimal point at the end, and you're going to slide it over 3 times. So 1, 2, 3 times. You would fill in a 0 here, and it's 0 and 35 thousandths. Who got 0 and 35 thousandths? All right, good. So again, the key thing is moving the decimal point however many spots you need to. Questions for me? All right, we're going to move on to some things here. We finished both of these problems, correct, on page 31?
Yep.
All right, so, and we did this one for homework, find the greatest common factor of 12 and 15. All right, good. Let's go over that really quickly. So when you have small numbers like this, I really think just making a T-chart of the factors is going to be easiest for you. So 12, what do we multiply to get 12? 1 times 12, very good. 2 times what will give us 12? 6. And 3 times 4. Now some kids earlier wanted to rewrite, you know, oh, then you have 4 times 3, 6 times 2. No, you just need to list it once in that chart, okay? All right, 15. Let's go ahead and do that. 1 times
15.
And what else?
3 times 5.
3 times 5, and that's where we are done. So what is the greatest number that is common to both lists, Paula?
3.
3, very good. So it's not a very big factor, but it is the greatest of these two numbers. So the GCF of 12 and 15 is 3. Right? Any questions on the list method of doing this? Right? There is a flaw with this when you're finding greatest common factor. Sometimes you might, when you have bigger numbers than 12 and 15, you may forget a set of factors, and that could really get you into a pickle, so to speak. So what we need to do is look at some other methods today. So yesterday in our notes, now this is the module's explanation of this. All right, they've got, you know, some of the trees. I teach it a little bit differently, and then they've got these Venn diagrams going on. If you guys could go to the back of your module book, I'm going to show you how to do it. All right. So I'm going to start you off with these two numbers, 96 and 64, and we are going to create factor trees. Now these factor trees may end up looking a little Charlie Brown-esque, all right? Sometimes they come out neat and very symmetrical, and sometimes not, and that's okay, all right? So So what we're going to do with prime factorization, which you guys already took notes on, I believe. Yes, you did. That's where we break a number down into prime factors, okay? So it's only a set of its prime factors. Now, how we determine this is the prime factorization is we start with a number and we have to then figure out what do we multiply to get 96, all right? So what are some numbers that we can multiply to get 96? Well, some kids are looking at this and they're like, I don't know. If you see an even number, you have a great starting point, right? An even number is always divisible by 2. So in this case, if we divided 96 by 2, do you know what that would be? You can go to the side and do that division if you need to. Yes?
Aren't you missing one?
Great point, Maddie. So we could always go 1 times 96, but you're going to get into a vicious loop of 1 times 96, 1 times 96, right? Yes? 40, nope, not 47. You're off one.
48.
48. Yep, so if you take 96 and divide it by 2, you're going to get 48. So you could do 2 times 48. When you're done, you're going to be listing these factors in order from least to greatest. So because of that, I recommend that you put the smaller numbers instead of putting 48 times 2. I'm going to recommend to you, it's not necessary, but put the smaller numbers to the left so that when you're done, there's less shifting around, okay? So now we have to decide, is this a prime number or is this a composite number? So if you see a prime number, you're going to be like MC Hammer and say, can't touch this, okay? So we can't break that down any further. You can't touch this. This is a number that only has the factors of 1 in itself. Now if we have 48 here, that's not a prime number. What do we call numbers that are not prime? Composite, very good. So 48 is a composite number. We can still break it down, all right? I'll save you the cheesy dance moves. Or not. I don't know. No one watching this is going to know whether or not I'm really doing the dance moves. See, you can tell by the laughter, that was a yes. Okay, so 48. How can I break that down? Now we have options. Michael's going to say what?
2 and 24.
Very good, but someone else may say something different, right? What would you say?
12 and 4.
All right, now it doesn't matter. Wait, what did you say, Michael?
2 and 24.
2 and 24, you said 4 and 12, right? It doesn't matter which one we pick because when you are done, if you have done this correctly, it will match. Everyone in here could, do it slightly different and they should all have the same prime factorization, okay? So let's use a different one. Let's use 6 times 8. Aha! All right. Each row is going to multiply to give you that number of 96. So right here we need to bring down our 2. So you keep bringing them down. I know some people teach, I know when I was in school we did not learn to bring that down. We just kept it where it was and didn't keep bringing down the prime numbers, but I think it's easier if we do bring them down because at the bottom all of your prime numbers will be listed right in a nice row. It could get confusing, yeah. I mean, you'd just be looking for the circled numbers, so it's not that bad, but tomato, tomato, everyone's got a different method, whatever works. So in my class, I'm teaching you this way, okay? So 6, we can break that down into 2 times 3, right? So 2 times 3. Both are prime numbers. Can't touch this, right?
Can't touch them both.
Right, can't touch this, can't touch this. It doesn't sound as good if you're not singing it. All right, so 8, another composite number. We need to break that down. What can we break down? What? I got giggling girls in the back of the classroom. Cruz. 2 times 4. I'm going to put the 2 in front. I'm going to circle the 2 because that is a prime number. All right, so this row, if we were to multiply this, we would get 96. We have to break down 4. Yep. So we got to keep going. Break it down. Do, 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 do. All right. Bring down all these prime numbers. That's a 3. That's a 2. There are a lot of 2s. When you do prime factorization, when you're at the bottom row, it should only be prime numbers, okay? So this is our lopsided prime, it's our factor tree, okay? And it's the prime factorization of 96. So what we would do now is take this bottom row and we would write down all of the factors in order from least to greatest. So I have a total of 5 of these 2's being multiplied together, and then I have a 3. And if you multiply that out, you will indeed get 96. 2 times 2 is 4. This is a group of 4, 16. 4 times 4 is 16. 16 times 2 is 32. 32 times 3 is 96. So that works, okay? If you check that at the end and it doesn't multiply to give you your original number, then you're missing something. Yes?
Or you could put 2 by the power of 5 times 2.
Abby is ahead of her time. She just said we can write this with 2 to the
Power of 5.
power of 5, yep.
Times 3.
Very good. So here's a little preview into exponents. So you have 2 being multiplied by itself 5 times, so you'd say 2 to the 5th power or 2 to the power of 5 times 3 equals 96. So either one of these is what we consider the prime factorization of 96. Notice that these are all prime numbers here. They're all being multiplied. You get the product that is our original number, okay? Yep. On your homework tonight, that's what you need to do. You need to make the factor tree and write the prime factorization. I had a kid earlier say, Mrs. Lehman, is this right? And they just had the list of numbers and they didn't put the multiplication dot between them. So it looked like 222,223 equals 96, which is not a true statement at all. So make sure you don't do that. All right, so we're only part way there. We've got to now finish this one, and then there's a few more steps. So 64. Why don't you guys practice this one on your own? We'll see if you all get the same thing. Okay, we're back. This is what the one factor tree for 64 would look like. We've actually, I didn't record it, but we went through a different way, and any way you cut that up, you're still going to end up with the prime factorization of 2 times 2 times 2 times 2 times 2 times 2, or 2 to the 6th power equals 64. All right? Any questions on that? All right, so now we've got to figure out how are we going to use this to figure out the greatest common factor. So I like to use the analogy of playing Go Fish. And when you play Go Fish in the math world, you're looking for a match, okay? So let's pretend 96 has this deck of cards and 64 has this deck of cards, and they can only make a match if, you know, the other player has those. So in the past I used to tell kids to just cross the numbers off as we match them, but I think that gets confusing because then you're messing up your prime factorization list. So we're just going to put a little check mark above them, okay? So, for example, 96 is going to say, hey, 64, do you have a 2? Yeah, I've got a 2. That's a match. You put the pile of matches together, okay? You're creating pairs of these numbers, but you only write it once, all right? So 2 and 2 is another match. Is a third set of 2's another match? Is there a fourth set of 2's? You betcha.
What if there's a number?
Hold on. All right, so we're gonna have a 5th match. Now, we have a 3 here on the 96 side, right? Is there a 3 over here?
No.
No. We have a 2 left on the 64 side. Is there a 2 over here? No. So if there's not a match, it doesn't go in our pile, okay? So you may have some, obviously, that don't have matches. So 2 times 2, because they're not the same number. 2 times 2 times 2 times 2 times 2. If we multiply that, we're going to get the greatest common factor. And it is not 10. We're not adding. We're multiplying. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is, you just found the GCF of 96 and 64. All right? So let's write the GCF, the greatest common factor of 96 and 64 is 32. I probably should have written that like there. Woo-hoo, fancy. All right, so that is how you do it. You make a factor tree for both numbers. You pull out the common factors that have a match, and when you multiply those matches together, you're going to end up with the greatest common factor. Okay? Xavier. Yep, sign out. All right, so why would using a factor tree be useful rather than a chart or a T-chart thing? Maddie?
Maybe because it helps you get all the factors?
Actually, this isn't going to tell us all of the factors.
Or like, it helps us get the greatest common factor easier?
Easier, yeah. I think it's easier when you have what type of number?
Prime?
No?
No.
Prime's real easy because it's just the one in that number, right?
Yeah.
When you have numbers that are
Positive.
somebody said it back here, Jenna?
Positive? Or big?
Big? Huh? All right, now, do you think you want to list all of the factors of 128? Is that going to be real easy? You're going to be able to rattle those off like that?
No.
Probably not. All right? 80 wouldn't be as difficult, but if it were like 380, you might start to go, huh, wait, what am I missing, right? So this is a way for you to get to the greatest common factor without the fear of missing any, all right? Missing any of those factors. So let's try to do this one. 128. Let's go ahead and start. Do we want to do this together, or you want to do it on your own?
Together.
All right, we'll do this one together, and I'll let you do 80 on your own. All right, so again, I'm looking at this, I'm saying, oh, even number, easy starting place, right? I can divide it by 2 then. So I'm going to put 2 times what? 64. This number seems familiar, kind of, now that we have 64. All right, 2, can't touch this. 64, break it down, all right? What can we break 64 into?
2.
Some people are saying 8 times 8. Some people are saying 2 times 32. What did we do the other time? We did 2 and 32? Yeah, so let's do 8 times 8 then. All right, 8 times 8. Those are both what type of number?
Even.
They're even, and they're also composite. Very good. So we're going to bring down this prime 2. All right, 8 and 8 can be broken down. 8 can be broken into 2 times 4, and same with this one. We're going to circle the 2's, bring down this 2. So it's 2 times 2 times 4 times 2 times 4. Break down the 4 into 2 times 2, and the 4 into 2 times 2. We can't forget this guy. Bring them all down. All right, those are all prime numbers. We can't touch those. We're going to circle them. And you break down a bunch of 4's, right? You have 2 times 2. That'll do it.
I only got 4.
Because you're not bringing down. You've got to make sure you bring this one down. Keep bringing it down every line. All your primes get brought down from line to line, okay?
Is it 6 or 7 2?
1, 2, 3, 4, 5, 6, 7.
Well, if we do the 2, and then will it be 6 or 7 for the top?
The exponent, so the base would be, it'd be 2 to the 7th power. And that should equal 128. All right? Let's write that out though. 2 times 2 times 2 times 2 times 2 times 2 times 2. Do I have some? 1, 2, 3, 4, 5, 6, 7. All right, Michael, do you have a question? You're breaking it down well. What you're forgetting to do is bringing down. See this 2? You didn't bring it down to this line. So you got to draw a line from here to there and write down that 2. Yep, and then bring it down again. And you never broke down this 8. So you're missing. You circled 8. 8 is not.
I didn't circle 8.
Oh, that's okay. what are you missing here? 8 times 8, 2 times 4, 2, 2 times 2, 2 times 2. You forgot to bring down that 2 and that 2. You're missing these 2. You got to make sure you bring them down each time. There should be either a number being broken up with this or a line coming down for each one. So you were leaving some up here. And what I'm going to recommend too, I'm just going to point out the mistake Michael made because he said, hey, I don't know what I'm missing here. He was forgetting to bring down these 2's that were already circled and we've already dealt with. Bring them down each and every time, okay? You can't leave them up here. They get really upset with that. Okay? Does that make sense, Michael?
I did it on all the other ones too.
You did what?
The same thing.
You brought them down.
I left them.
No, you brought them down. I'm looking at your paper. You brought them down. I think you just missed some. So what I'm going to recommend, guys, is like, so like the 2 and the 64, maybe you got to like space yours out further because, you know what I mean? Like space the top out a little further so it gives you more room to keep branching out. Because it does, that's probably the benefit of not bringing them down is, but you've got to make sure every line, if you've done this correctly, every row will multiply to give you 128, okay? So you've got to make sure you're bringing down the right amount of 2's every time. Does that make sense? All right, so I think what is happening is people are cramping their work and they're not bringing it down, okay? All right, let's have you guys work on 80 by yourselves and we'll come back to finish this video. All right, so we've got 80 broken down into 2 times 40. You'd break that down into 2 times 20, right? Bring down this 2. All right, 20 can break down into 2 times 10. Keep bringing these 2's down. And then 10 would break down into 2 times 5, both of which are prime. Can't touch those. And you're going to end up with a prime factorization of 80. So 2 times 2 times 2 times 2 times 5. That would multiply to give you 80. On your homework, they are going to ask you to do the prime factorization of some number. So it's asking that you write this on that line. Okay, and then other ones, they say, here is the prime factorization. What was the number we're talking about? So it'd be like if they kept the equals 80 off there, you just multiply. Just multiply and say, what number was that? Okay? So, thank you for watching Math with Mrs. Lehman. I hope, oh wait, we didn't find the GCF. What am I doing? All right, we've got to play Go Fish. All right, so 2 and a 2. Check. 2 and another 2. Check. 2 and another 2. Check. 2 and another 2. Check. Oh, we're out of matches there. Is there 5 in either list? There's 5 in this list, but not in this list. So we are done. So 4 times.
Wait, 2 times 2 is 4.
I'm missing one. I'm missing one of the things. I forgot to bring down 1, 2, 3.
No.
1, 2. What am I doing?
No, I got it's the same.
Am I right?
Yeah.
It's only 16?
Yeah.
That's it? Okay. Blooper. This whole channel's a blooper reel. I'm not too worried about it. All right, so anyway, it's okay to like go, am I right? And then check your work, kids. That's helpful. So anyway, the GCF is 16. All right. Thank you. Thank you for watching. Please don't forget. Wow. These kids are going to wait until they're quiet before they're dismissed. All right, guys. Thank you for... We're going to try this one more time. Thank you for watching Math with Mrs. Lehman. Have a great day.
Bye.